still looking for a volunteer for Jabber? Anyone?
Oh, nice. PowerPoint just crashed. We may go on your PDF. So
Okay,
just
the
slide through.
This is for Jabber. I see you just volunteered, right? All of them.
Oh, yeah.
Okay. See where that one works. What's that? Oh, so if I use the PowerPoint, I'm fine.
Yeah.
Yeah. So.
Okay.
So then I go to presentation mode. I'll give it a shot.
Because that's what I would say. We have everything really big.
We still need someone to cover.
So this is just an extra mic.
So anyone for Jabber? Dave Allen. You came in as last. Would you be on Jabber? Pavan, would you please be the Jabber scribe? Thank you. So good morning. Welcome to Prague. We are opening. So we'll go through agenda and passion. Good to see you all. So Note well has been updated since this IETF. Please read it. It says pretty much same thing, but some different wording. So be familiar before you publish, present, or disclose any information. Our process will poll authors before adopting working group, as well as going through working group last call, and unless every niche author has responded, the document is not going to progress. Well, thank you, Injing and Ignas, for taking notes. Thanks, Pravan, for being on Scrubber. And please welcome our new secretary, Injing, since last IETF. And please, when making comments, when presenting, please state your name, because the room is large and complicated. So agenda for today. Agenda for Friday is somewhat shorter. We've left some time for discussion, and we'll probably share some time with MPLS who needed more time. So our extended and approved charter to look into topics that might be outside of any other working group. We've got one new RFC published. Thanks AC and co-authors for great work. They've rewritten the document at least 10 times. Just before publication, it was also brought into way we recommend to do the revised data store. So great work. And probably a very good example how YAML model and IETF document describing the model should be done. YAML creep and YARVRP are ready. So we have requested the publication, they're in process. Routing types are in working group last call. BGP peak and microloop delay are working for Shepard's write-up. Shepard is sitting next to me, so waiting. Yes. So YANC and 9 LNI models are ready for working group last call and going to be last call after IETF. So we've got a number of working group drafts. Some of them are ready for working group. Some of them are still need to be discussed. So it would be great to see more discussion on the list. There are quite large number of non-working group documents. Again, would be really good to see more discussions, presentations in upcoming IETFs. So some drafts could progress, some drafts could be removed. So the significant number, as I said. That's all. Yes, please.
Bruno Lecrun, Orange. Last meeting, we asked for working group last call for SPF algo, SPF backoff algo. So what is the status?
So you need to handle that because.
Yeah, I'm a co-author, so that's up to Jeff. I don't want to influence him or anything, so I will let him respond.
So chairs discussed it, and we think it's ready to progress. And
Okay.
after IETF, we'll progress.
Okay, thank you.
So first presenter. Please stay.
Okay, this is the this is a really simple Yang document, and it's an attempt to call to put the common types into for routing into a single Yang model. So this model doesn't have anything but types in it, and a couple groupings, and it's really a corollary to what we have today for IETF Yang types. This is IETF routing Yang types and IANA routing Yang types.
You could look.
Oh. Let's see here. There we go. So, since actually the Yang Doctor review was before the IETF in Chicago, but we've had the Yang Doctor review. We've at Chicago we had some discussions about whether or not the BGP SAFIs were common across a number of models, or they were specific to BGP, but it doesn't hurt to put them in the common routing types since they're well known and they're in the IANA directory. I mean, they're in IANA registry. We also got a comment from Rob. He wanted 2 new types that were in the open config types and were actually used by the current BGP model. So we put those into the IETF routing types as well. Nice thing about Yang, since you have the prefix, there's no problem with duplication. There's no ambiguity. So you can migrate types from one model to another seamlessly. Then we had a second Yang Doctor review from Rtgwg, and at that time, the RFC 6087 BIS document had an appendix with a boilerplate. And there were some other things we did as we put the boilerplate into the Yang models. We also we did not take the security considerations. The reason, the boilerplate security considerations. The reason we did not is these are only types. So it's not really a Yang model. You wouldn't use RESTComp or anything on this model. And then we split the routing types into IANA routing types. So we put specifically the address family and the BGP SAFI into a separate module. Still in the same model, but it's a different module. This is the IANA routing types model. Not enough coffee yet. Okay, we've gone through routing directorate review, working group last call, and during the working group last call, Jeff suggested we add IPv6 route target, route origin, and IPv6 route origin as per comments. There's more on that in the draft, so I won't go into it. And we also added the geo coordinates. Now I'm on one of the geo coordinates drafts, so I was familiar with the encodings, and it was good to get those into Yang encodings, but I'm not going to go through those because we had some discussion among the author, and we think this is the most risky to put in this early because none of those documents have really gotten a lot of review by the people that are the location experts. So we're going to defer that and put those into a different module and a different draft. I see Jeff's at the mic.
Just for the record, the last lingering item I think for the extended community stuff is extensibility.
Yes.
And we still need to resolve that, and we'll hopefully get people together this IETF to talk about that.
He's a plant. I got that covered in my presentation. So I already talked about this. Along the lines, right now we already have an RFC standard. I forget which one. It's RFC 72. It's not 7223 because that's the one for the interface model. I think it's 7224, and that's an IANA IANA interface types that includes all the interface types in IANA. Along those same lines, we created a new model, the IANA routing types model, that has all the registry. I mean, it has every address family that IANA has and every BGP SAFI that IANA has. This is about how we did it. We used identity rest so that it could easily be augmented with a base identity and a unicast, and then for all of them. I just showed 3, but you can see that how we did it. And then we have this was, okay, yeah. So you see, this was actually the BGP SAFI snippet that I showed. And I think there's about 25 SAFIs or so that are defined by IANA. Now the idea is that IANA would actually own this model and update it. In practice, I don't know if that's worked yet. I know we're working, if you go to the NetMod working group, there's all sorts of discussions about how we rev these models quicker than the RFC process. These are the 2 that Rob suggested I add. I took them out of the GitHub for the open config types. And see, I got a separate module. I took these out and I put all the address family and BGP SAFI into this module. These are both in the draft. Here's the IPv6 route target. Now, one of my things, I got an email yesterday from Benoit, and after the hackathon, they got a new tool where you can put in from 1 to n patterns, and you can actually evaluate test strings against it. So similar to all these web tools to evaluate regular expressions, we'll be able to do the same thing with not one Yang pattern, but a list of Yang patterns. So that'll be really nice. Not only be able to write these patterns and then have to go all the way to some kind of Yang tools where you're actually got a harness and you're actually have a client and server unit test. You can go right out to a web page, add your patterns in, and test various strings against it. I haven't tested it myself. He sent me an email on it to do it. I'm planning to do that this week when I get some time. But this is the route target one. Oh, there's Benoit.
Good morning, so I'm Benoit. Right, so there are two different codes to test the W3C regex. So I would appreciate some testing on both of them. We put two outputs to be able to compare the two tools. So one is based on YangLint, the other one of convd. So testing is appreciated. We also added in there like the invert match in case you need it.
Benoit, could you please send an email to the routing working group mailing list asking people to...
I'm trying to recover from Bruce screen after that. Yes.
Would be great. Thank you.
So the IPv6 route target is an IPv6 address with a mandatory colon followed by a number from 0 to it's a 2-byte number, 65535. So it has the whole range of a 2-byte integer. Then the route origin. We have the route origin is the same as a route target, only it adds this arbitrary pattern so that you could have any any 2-octet hex number followed by a 6-octet hex number. And the IPv6 route target origin has the same pattern as the IPv6 route target. Now, the route target, one of the comments, the comment Jeff was talking about for extendability, there's a number of ways we could do it. We have the ES import. I don't know how I did get this in the originals. Actually, Shifang did the original, but I don't know how I didn't add this because I've made some modifications to the route target and the IPv6 route target. From EVPN, there's the ES import route target. We missed that format, and that adds the type 6 route target. Now, what we could do is we could either add, like we did for the route origin, we could add this generic type of Yang. We could cover anything, or we could add the type 6 route target. Now, or we could add both, and that might be the best solution, to explicitly add the type 6 to cover the case of the ES import from EVPN, and then add the generic one as well. We'll talk about that among probably Jeff in the office. Anybody else has any input, that I would appreciate it. So, the only things pending change on the draft, we're going to do something with the route target, remove geolocation grouping. That'll go into a separate module. One thing I forgot to mention. Now, a question is, because this is already a working group, if we had a real short draft of that, would that go right to a working group document?
So the draft has been under working group last call for quite some time.
No, I mean, if we take this out and put it in a separate draft.
Yeah, we could do so.
Yeah, it could go right to, okay. And we're also going to improve the description of the label stack, grouping semantics. Loa initiated the discussion of that on the MPLS list and issuing a version for publication.
So actually, I want to go back to, you're asking specifically about removing geolocation grouping?
Yes.
Whether or not, if that got removed, when it gets removed, if that could go immediately to working group last call. I'd have to look.
No, not working group. It's a working group document. Sorry,
Okay.
I said it wrong. I said it
Okay,
wrong.
that's what was confusing me here.
Yes. No. The reason we're taking it out is because we don't think it's mature enough.
That was my concern.
Right.
given the changes to the document, I think we will reissue working group last call, and a lot of comments came in very late.
Mhm.
So after you kind of you stop all the pending changes to the drafts and all the points,
Yeah.
we'll reissue working group last call and take it from there.
Okay. Yeah, that's what I had for that.
We need to finish this up because
We're
of the
done.
10 minutes. Good.
Yeah, I think I've gone through all this.
One last question, statement from Jeff.
Yes, Jeff, I was, one last thing that I don't remember if I mentioned on the list. The target types and other things are part of a module that's not IAM maintained. Is that an oversight or is that intentional?
I don't want them to be myself. I mean, yeah, you think we should put them in?
So the reason they actually have it IAM maintained is that, for example, the route target type, if you're going to have that be extensible, if you don't make it IAM maintained, it means that the working group has to pick up a new working group document every single time, whereas if it's IAM maintained, it's a lot more flexible to have it quickly revved. That's something the working group has to
Yeah.
decide, and the chairs
Yeah.
probably have an opinion about it.
I know there is a registry, but it's for extended. It's not. It's a general extended communities registry, and this is a specific route target type.
Well, it's pretty much everything that's inside of that submodule.
Yeah. So it's not really completely aligned with one IANA. We don't have one Yang type that does all the extended communities.
Right,
That's-
but my general point is all the types of things that are in that module right now that you probably do want to actually be maintainable. You have to decide if you're going to make this go through the working group, every single time you touch it. And this seems like a fundamental piece.
We need to move on here for the schedule. I'd said that Jeff was the last question on this.
Just short info. The discussion.
Excuse me?
Just a short info on discussion on the label stacks. We said that we will take the discussion on label stacks in the MPLS working group. We will do that, but it will be on Friday morning. So if people are interested, they should be there after the routing area working group.
Okay. Thank you. Laszlo Anderson.
Hi, I'm Lou Berger. I'm going to give an update on the routing design team, I always love this name, routing area Yang architecture design team, as well as some drafts we're working on. So we have 3 drafts that have come out of the design team that are now standards track. One of them you just heard about, 2 of them I'm going to talk about in a moment, and those are the LNE, not LNI by the way, LNE and NI drafts. We have a couple of other drafts that are headed for netmod. The first one is the module tags. This is sort of hashtags for Yang models. That was, not much has happened between the last IETF and this one. We had asked for feedback. We didn't get any, so we're going to proceed along with our intended path, which is to do an update to that document in netmod, and then update our logical organization using tags. And we expect that before the next meeting. I'm also going to talk briefly about what's going on with NMDA, or our friend Upstate. So the ADs have issued guidelines on this. The 2 ADs who issued that guidelines are actually in the room. If I get it wrong, they'll correct me. First thing is, how are we going to deal with the whole Upstate discussion? We have in netmod the network management data store architecture document, which is the revised data store for representation of operational state. That's happening in netmod. The protocol support's happening in netconf. The direction is all models being developed at this time should conform with the guidelines and the structure of NMDA. That means that we don't represent operational state in our models anymore. That's a little bit of a big change. For to access that state information, we'll have to use the new NMDA approach. Those NMDA approach, while the architecture is defined, the protocol access has not yet been defined in netconf and restconf. So we have a gap in capability if we do follow one. For those protocols or for those models that need access to system created state or operational state, need to differentiate between operational and configured state, there's a transition approach, and that's what's covered in number 2, is that it is okay to have, for a well-structured NMDA model, it's okay to have a companion model that represents operational state and system created state, but that should be published in an appendix, and with the expectation that that appendix is going to be deprecated over time. Rob Wilton, who I think is going to talk in a little bit, well, I think he'll mention that there, for a nicely structured NMDA module, that there's some tooling out there to take you from a NMDA compliant structure to generating this appendix. You can use that tooling, or you can do it by hand, whatever works for you. Just publish it together, the base model, which will be good for the long term, together with the transitional support that's necessary. We're going to hear quite a bit about that, I think, or at least a little bit about it. We're also going to, if for those who are really interested in this topic, come to NetMod, and there's going to be even more discussion. And there's a Q&A session there. It's basically unstructured. If you have questions on how this all works, go there, ask your questions. So in terms of short term, if you're developing a model in the routing area, so this means this, folks in this room, you should restructure your model to be NMDA compatible. And the reason I'm intentionally using the word model is you may end up with multiple modules. So you may have today one base module that you'll have to break into 2. There are, we have one existing RFC that really impacts the area, and that's the routing config. That RFC will need to be changed. It's not a big change. I think we've gone through, when I say we, collectively as a group, have gone through and figured out what those changes are. We're expecting AC, excuse me, as well as potentially someone from the NMDA design team to issue an update on that, hopefully not too long. I know there was some hope in having it in this week, next week, but you know, it's not that, I think it's a little ambitious, but hopefully we'll have it soon. Moving on, trying to move on. The clicker is not clicking. Next, please. Sorry, user error. So moving on, I'm now going to give you updates on the 2 documents that are used to represent logical separation of a physical device. So we have the logical network element model. This is to give virtual systems. Think of this as VMs for routers. That's this one. We're going to talk, the network instance is all about VRFs and BSIs. That's the next one. Mike, please.
The previous presentation,
Name?
were you taking, excuse me, my name is Susan Harrison. In this case, I am asking you a question as the IDR co-chair on the previous model. Is
You're
this
talking
the
about
time?
this slide?
Yes, is now the time to ask questions, or is it
Sure.
later? So we have a model that's been adopted by the working group for over 2 years, deployed with about 15 implementations. And because it's not through the process, it's persona non grata. Is I understanding you?
So you're asking me, a
I'm
design
asking you
team
what-
lead of what's happening in IDR?
No, I'm asking you about the previous slide.
This
One
one?
more back from this. It's a clarification question.
So this is ADs speaking?
I-
So I would ask the ADs who are in the room to respond to the question, because That's their position.
Okay. I just,
I think you're asking, what do we do about the BGP model, right?
yes.
Oh yeah, this, so there's a reason it says should. This is the desirable thing. For some of the models, there's a case by case. And the BGP one certainly falls into the discussion category.
Yeah, the BGP model, as someone who's tried to use it, has a problem that it doesn't even compile right now.
Exactly.
So,
Yeah.
so from an IETF perspective, I would expect some discussion in IDR to talk about what the plan is to take it forward in a way that is functional. And I'm not talking anything about the NMDA split. That's up to the working group. That's not for us to say. There's the guidelines out there. You've heard from the AD. She says, you know, that's, you take it on a case-by-case basis. I think IDR should discuss it. From a usability standpoint, from the design team, we have looked at it, and one of the issues is we can't compile it.
I would point out the compiler, since it was adopted and checked, has changed. I'll just point it out that that's a historical moment, not rather a fault.
Yeah, but
I'll be real
I think
quick.
also the fact that there's been a lot of uncertainty over this issue has made some models be put on hold and wait until this is done. So I think it's somewhat unfair to criticize it as not compiling now.
Well, it references types that aren't IETF.
Right. So this
it's not gonna-
process,
yeah.
this process has created a lot of uncertainty over where to go forward. So the fact that a group hasn't updated their model in the last few months to keep up to date, I don't think says this is a bad model. But let them decide. When they decide how to go forward on the NMDA stuff, they will update it so it works. And I think we can move on.
If we could find some time after IDR maybe and just discuss the way forward. Yep.
Yeah, so the conversation in IDR sounds right. This is an AD statement, the AD has stood up and said that things can be taken on a case-by-case basis, so I don't think there's anything that should be blocking at this point. We do have a transition period to deal with, and that means we can't do the ultimate desired solution immediately, so we're not in a perfect state. That is a true statement. We have to figure out how to best manage the transition so that we continue making progress and bringing value in a period where we know some things are changing. And that's what the approach of having a core model that's going to be the long-term core structure, and having that in the body of the document, yet still providing an appendix where needed for the temporary or transitory, which we know will last a while, because we know once something is implemented and deployed, it's going to be used for a while. So I do want to get through these next two updates. I think we spent more time on NMDA than I had budgeted, so I'll try to speed up here. We have two documents that have been around a while. We think they're really mature. We'd like to get to the point where we can go to last call, as the chairs mentioned. So I want to give you an update on what's changed and an opportunity to ask questions if you have them. Both documents were previously blocked on some technical issues being resolved in the schema mount document. Both use this new capability, this new Yang capability of being able to essentially import a whole module. Previously, Yang had the ability to import sort of, think of them as data structures and groupings, but you couldn't import a whole module into another module. Schema mount gives you that capability. There was a slew of open issues. The core open issues have been resolved. There are a couple of small things out there. I'll mention one of them in a moment. Our feeling is it's not critical to resolve those right now, and we'd prefer to get the capability out there and schema them out. And so we're just going to use it as it's currently defined, with an assumption that nothing changes. And by taking that approach, we can unblock both of these two documents. So there's a whole bunch of little details in our update and why we did it. We got some great feedback from the routing area review, as well as from Yang doctors. This applies to both documents. We've updated both of them for that, and we've made a couple of technical changes. I'm going to talk about the technical changes now. Excuse me. The first thing we did, do we have a pointer? Yes. Yes. The first thing we did is we picked up a new tree representation. So there's now a way in the trees document, which is also a netmod, to represent a schema mount and mount points. So the first thing we did is I don't see, oh, there we go. So we have a mount point indicating where the logical network element root is. And the other thing we did is we added a notification. So one of the discussions in the whole OpState discussion was the ability to have transactions to be processed asynchronously and being able to support that in a good way. And we realized we needed a little support in our model for that, because you might have a transaction that creates an LNE and binds an interface to an LNE that returns immediately saying, sure, we're going to go work on it, but some asynchronous processing happens inside the router, inside the node, that makes that fail later. And we didn't have a way of identifying that. So we now have a notification that allows that information to be provided. So you can have a transaction that completes successfully that says, yeah, we found the LNE, but in fact, an RPC is taking place, and then later on, there's a failure. That notification can happen. Also, this can be used in normal operations for internal errors. We have an example here of what the tree would look like in an actual LNE. So in the model, the formal model stops at the root. When it's instantiated in an actual system, and this is decided by the implementation, by the way, this isn't something that shows up in the standard. An implementation decides what gets represented in, think of it as a virtual machine. We can have, for example, Yang library. Actually, we require that. That's the one thing we require. And then you can have whatever modules are implemented for a typical node. I'll point out here, and these are highlighted in blue, that there's now a tree representation for mounted modules that show up with a slash at the end. Don't know about that animation, sorry about it. So at this stage, we would like some additional feedback and then move to last call. I'm going to move on to the next model. If there's questions on LNE, take it now. How am I on time? Probably like 5 minutes? 3, okay. So we did the same update on network instance. One of the, you can see the netmod chair coming to the mic. Or
Kent Watson, Juniper Networks, as an individual contributor on the previous model. The notification, I was wondering, should that be a generic mechanism, not specific to routing module?
So this is the notification is bind LNE name failed. So the notification is pretty specific. So I'm not sure what would be generic here.
Of course, it wouldn't be this name, but in the OpState Rex draft, there was a desire to have synchronous and asynchronous mechanisms for all updates.
Yes.
So I mean, currently we have it that the client would do a diff between the operational and the intended to figure out what actually got applied. But there was a desire for there to be some sort of notification, a generic mechanism. If there were, then would you still need this?
So do we have a generic mechanism for failures? In my opinion, we do. It's called notification. So we created a notification. I'd be interested in if you had thoughts on if there was a more generic way to do it, and then sure, if there's a more generic way to do it, we could go that way. Is there a better way to do it in Yang?
I don't know, just raising it for discussion.
Okay, if this isn't the best way to do it in Yang, we're happy to change that.
I was gonna. So yeah, I mean,
Name?
it seems this Chris Hops from Deutsche Telekom.
this seems like a pretty generic, when I saw this, I was like, wow, isn't this a problem for a lot more than just this one case? And I assume we're doing it, I think, because netconf processes things serially, even if they're asynchronously processed, right? So this seems like a bigger generic problem for netconf Yang, right? That you want to be able to process things out of order. And that's what this is addressing, right?
I'm not so sure it's processing out of order. In this case, it's a late failure notification. Or an
Right, but
asynchronous
the
failure
only reason you
notification.
can't, there's no mechanism to report a failure on an asynchronous operation in netconf Yang out of order. You have to reply to the, in order to message
Yeah,
IDs.
yeah.
So that's where we get this kind of problem from. So I'm just saying, I think it could be solved more generically than just for us than this one draft.
Do you think we should remove this? And you can speak as co-author because you're a co-author.
Yeah, I think we should after bringing it up in netmod or netconf maybe, I don't know.
Oops, I'm going the wrong way, sorry. So we made parallel changes in the NI model. We actually, I'm not going to discuss the parallel changes, I'm going to discuss the significant changes. One of the big open issues we had was how to represent the particular configuration information that we would have for each type of VPN technology, layer 2 VPN or layer 3 VPN technology. For example, how to represent the configuration parameters that you would have for a layer 3 VPN that's supported over MPLS, a layer 2 VPN that's supported over EVPN, or a layer 2 VPN using VXLAN or a VPLS or whatever technology you want. In the original version, we had a placeholder. Our thought was that placeholder could be, we would put some information there, but provide a sort of a rich structure to be augmented. We've simplified that, and we've created a choice statement called NI type. And the intent is for there to, each particular model that supports a layer 2 or layer 3 VPN technology to augment that. I do have examples on that, but I'm out of time. We're going to talk about that in BESS. So I expect to go through the details there and talk about the impact for, in particular, an L3 VPN. So rather than go through in the interest of time, I'll skip those slides. But if you're interested, show up at the BESS working group. That's NI type. The other thing that we did is we recognized that just for schema mount, that you have to have a mount point for the information contained within the VRF or VSI, and that really is independent of how that VPN technology or that VRF is supported over the core of the network. So this is common. We actually came up with 3 types, one which is VRF. Actually, I think I have it on the next slide. This was an example here, we'll go there. One is just for VRFs, the other is for VSIs, and then we have the hybrid case where you have something like a bridge router or something that does both L2 VPN as well as routing within the context of the VPN. So we support those. One really important thing that's confusing, seems to confuse people, is that the models don't dictate what goes underneath a mount point. It's the implementation that decides that. So an implementation, for example, can decide to implement a particular module underneath the root of the device, and it can implement a separate one within the context of the VRF. It doesn't have to implement the same one, and it chooses. It's an important concept, but I'm out of time, so I'm not going to spend more time on it. We have more examples in the document. We also have the parallel notification edition, and if for some reason we decide to drop it in the LNE document, we'll drop it in the NI. We also had one open issue. As I mentioned before, our thought is to just accept the limitation and move on. So we received one piece of feedback in this talk about the notifications. We have to run that to ground. Once that's run to ground, we're going to be ready for last call, or we can choose to resolve that as a last call comment. I defer to the chairs on that.
So ideally, we would like to resolve it, have it resolved before working group last call. Otherwise, we end up in the same very long class calls types. And we'll be looking for shepherds for both documents. So if you're interested, please let us know.
And if you do have comments on it, please do send us comments or questions. And let's do it on the list, because if you have a question about how something is organized, I bet you're not the only person. And while you may individually feel it's a naive question, there's going to be others who have the same question, because this stuff is a little confusing. We think once you get through the details that the models actually turn out to be radically simplified from where the solution space could have gone and where we started. And so any discussion that helps clarify how things work, we think will be good for everyone. So please bring it up on the list. And remember, if you're interested in the network instances, if you're interested in VRFs or VSIs, please come to BESS.
Thank you, Lou. Robert?
So I'm Rob Wilton, and I'm going to give you a quick talk on effectively some guidelines on how to migrate existing IETF Yang models towards this NMDA architecture. As I speak on behalf of the NMDA authors on this. Right. So just a quick recap as to why we're forcing on this change, or encouraging this change. What's the justification? And it all comes down to the OPSATE thing. That we want to be able to cleanly differentiate between what the operator is asking a device to do and what it's actually doing. And today, or historically, what's been done is often you've had to infer what a device has been doing from it's called the config false nodes. You don't actually know what configuration has necessarily been applied. So you don't know the difference between what you're asking to do and what it's actually doing. So this is trying to solve that problem in an elegant way. And at the same time, it also solves various other problems that have been coming up in IETF, like how I2RS should work and that sort of thing. So there's been loads of discussion for the last few years on this, and the agreed solution is an operational data store to represent operational state. Both netconf and restconf will be updated. We'll have additions to them to support this. That'll be discussed in netconf. The aim is to effectively, over time, to deprecate what I would regard as the broken get operation in netconf. And I regard it as broken in the sense that it's mixing both the intent of what an operator wants for the configuration and what it's actually doing in terms of its state. You're not binding the applied configuration and state together. But this does have implications on what the models look like, and that's what's going through IETF at the moment. So I'll cover those in a bit more details. So there's three different sort of model structures that we have floating around today, or at least three. The main ones here are a split config and state top-level trees. So, for example, interfaces and interfaces-state, for example, they're top-level containers. The interfaces container has configuration, and the interfaces state has the operational state. And you may have some duplication of the configuration nodes into the state tree, but that's not guaranteed. Now, the structures may be aligned, but again, that's not guaranteed. So because they're separate trees and modeled separately, there's always a risk that these two things deviate. The second style that we come across is the one that OpenConfig have been pushing, and that has config and state containers within a single tree. So you have one tree containing the structure, and then you have config and state containers underneath, and you have effectively the configuration under the config container, and you have both the configuration and the state under the state container. And so if you look at any of the OpenConfig models, they fairly consistently follow this structure, and it's a way of programmatically being able to look up both configuration and state. The BGP draft that has currently expired effectively follows this structure today, as did some of the TEAS drafts, but they've been updated to an NMDA style. So the future, or what we think is the future, is this combined config and state tree. So you've got one tree that represents both configuration and state together. And I'll cover some more slides to sort of illustrate that in a bit more detail. There's various models that have already been updated to this structure. The I2RS topology module and the T topology model, might be a couple of T's ones, have been updated to this structure. The intent, I think, and the hope is that everyone will go this way. So to put forward an example that is hopefully really fairly easy to actually illustrate this, I've taken a few leaves from the BGP model. Obviously, this is nothing like all of it. I've taken 4 global leaves, 2 configurable ones, the AS number and the router ID, 2 global state leaves, total paths and total prefixes, and then I've got 4 neighbor leaves here as well, which is under a list structure, so you can see what it looks like with a list. And again, there's 2 configurable leaves there, neighbor address and peer AS, and 1 state, or maybe 2 state leaves as well under messages, in and out message accounts. So what this sort of micro BGP model looks like with the traditional IETF split config state module is like this. So you can see that on the left in blue, you've got all the configuration nodes. You start with the top level BGP node. Under that, you've got the global configuration, and then you've got the neighbors list with I've got 2 neighbor entries here, the first and second neighbor with their configuration. Then in the BGP state tree, if you were to replicate all your config into state, you would end up with a sort of tree that looks like the orange tree. And the ones that are in a shaded dark orange, solid shading, are the config false nodes. Those are the state nodes. All the other ones are the duplication of the config nodes. And that allows you, using this structure, to still represent the applied state of the existing models, but you have the cost of having to effectively manage those 2 trees. And in the Yang model, to do that, you've either got a lot of duplication or you've got groupings, which make it more confusing. And in many cases where we've looked at this, the state tree starts to deviate from the configuration tree. You can't automatically compare them. The paths don't necessarily align. So what it's moving to, what NMDA looks like, is effectively like this. So you keep that same config tree that you had before, nothing changes there, but anywhere where you had those state leaves or state nodes, they migrate into the config tree. So you end up with one single tree, and it contains both config and state together. And effectively, you try and reuse as much as possible the same structure as the config tree, so you should try and align there. And then anywhere you want to have either leaves or trees of leaves underneath that config tree, that's fine. And this NMDA structure will work effectively, and we hope is the future of the Yang model. So once you've got an operational state data store, this tree will represent the state in that operational state tree, and the config parts of it will represent the configuration in any of the configuration data stores, like running and candidate, startup, and intended that we've added. So I'll just go back so you can see that's what we had before, and you can just imagine those trees merging together, and you end up with that. So the other example I mentioned was these sort of open config style trees. So I thought, again, it'd be useful to show you what they would look like. So this is potentially a bit closer to how the BGP model in the current expired draft looks like, because they were adopting the open config style. And so they have one single tree, BGP, like the NMDA style, but underneath that tree, wherever you've got any state, you end up with, or actually, whenever you've got any config, you end up having to create 2 containers at each level. So you see a config and state container appearing underneath global, and you see the same config and state containers appearing under first neighbor and second neighbor. And the rules that you use to build this style is that wherever you've got any configuration, you have all the config leaves have to have a config container directly above them. And at the same time, you create a state container with a duplication of those 2 config leaves, and you add also any state leaves you have as well. So all 3 of these representations effectively are modeling the same fundamental information. So there's nothing different with what's being contained in the models at an abstract level. All that's really different here is how you represent them. And it is our belief that creating this model ends up to you writing a simpler Yang model that's almost guaranteed to be more consistent, because we take away the inconsistencies, we take away the ability of people getting it wrong. So I'm just going to skip over what we think the advantages are of having this sort of combined NMDA model structure. We believe it's simpler and shorter to write, and it sort of minimizes the use of groupings. Certainly in the open config models, because of the way that they structured them, they have a heavy use of groupings, which makes them relatively hard to read in the source case. As I've also pointed out, that by aligning these into a single tree, you make it impossible for those config and state trees to become inconsistent with each other, so they can't become out of step. and deviate in their structure. And that should also mean that in terms of tooling over time, that will be easier. That if you want to find the applied configuration value, it's on exactly the same path as the configuration value, it's just in a different data store, and it's guaranteed to be so. In terms of this solution, it's fully consistent with all of the Yang semantics and language constructs. Again, that's not true with all the other solutions like OpenConfig. And the proposed structure that we're using here also takes into consideration support of other IETF work like I2RS, where they want to have dynamic data stores. And once you have that, then you want to work out how do you feed that information in. So in terms of the data store architecture, it has a clean way of supporting new data stores and having those feed in and understanding the semantics of those. And then the last observation here is that actually, if you really wanted to, you could generate either the open config style models or the split config state trees if you wanted to from this single source. So it still gives you a better structure to write, even if open config. So I've made a suggestion to the open config people that perhaps their models would be easier to read if they structured them this way and then generated their open config style trees. So in terms of migration, all Yang models produced by IETF should conform to the NMDA architecture. Personally, I think there's huge value if all the models produced by IETF and also IEEE, John Glenn, are consistent in their structure because it makes it easier for everyone to use. I understand and appreciate that the Open Config have chosen a different structure for their models, but they're very strong in their consistency between those models. So you know that if you're using Open Config, this is how they look like, this is how I write tooling to work well with them. And the proposal here is, again, that if all the IETF models conform to NMDA, then when people are using those sets of models, they have a common expectation of how they're going to work, and they can write their tooling based around that assumption. So effectively, as I was discussing in the slides before, any nodes, in terms of how you migrate, any nodes that were in state trees get copied into the config tree. That's all that needs to be done. And that's for models that follow this sort of existing IETF split config state. So, you got a question?
Comment after you finish. I was trying,
Okay,
I'm
sure.
just politely listening. Thank you.
So, and if you've got the open config style, again, actually, they're easier to migrate than this because they already sort of have the same structure. You can just move the existing state leaves straight across and delete the config and state containers. So, and I'll speak to Sue later about this. I had a go at doing this on the BGP model a few months back, and in an afternoon, I was able to create an NMDA compatible version of the BGP model that that's currently published. And fixing the sort of compile errors and things, the same thing. So that's relatively easy to do at the very high level. You then have a question of whether you want to remove the extra groupings that are no longer required. So in that case, you can spend more effort to clean up the models. The last thing that's worth pointing out is that now you've got the same nodes representing config and state. In terms of those descriptions, whereas they previously might refer just to config, you might need to update those descriptions to be more generic and apply both to config and state, or explain the semantics in the two. Yeah, so Sue, now's a good time.
Okay. Thank you for the excellent BGP example and the side comments. I guess I do have a question, a comment. I would encourage you to, we have extra time to and sometimes IDR to present this in IDR and hear what the operators have to say. That leads me to my second question. Have you in any of your hats, IETF or perhaps your corporate hat, asked operators what they think about changing this BGP model from the existing deployed ones?
So in terms of presenting this in IDR, yes, if I'm free, I'm happy to do that if there's time available. I'm also presenting this in NetMod as well. I don't want to overload people with the same presentation. In terms of the BGP, personally, no, I don't know. So I think that comes down to whether people are implementing the open config models in the industry or the IETF models. And at the moment, I think there's some hesitation in the IETF models because they're not being published as standards. They're not actually getting passed through the door.
So, correction, the model that's in IDR is still adopted. Whether you consider it expired or not is another thing.
Yeah.
It is still adopted.
Okay.
So I was precise in my question. Have you talked to people about abandoning the published BGP model for this new methodology, and do they feel that it's a value add for their implementation and deployments?
So the straight answer to that is no, I've not
Okay.
spoken to them. But I would like to say, but the model that you've got in BGP and IDR is the open config model. So that will still continue to exist in the open config ecosystem. That's not going to go away.
I will restate that you are incorrect in the way you're stating it, but let's go on beyond that and continue it.
Okay.
Okay, so you're saying that you feel that this is going to be better and that we have something to tell our operators that this is a good reason to change?
I believe so, yes.
Okay, and the reasons you're telling that, again, as the IDR chair, so that I can give your opinion and not my own, what do you feel is beneficial? For the switch between the two models, because it's a rewrite in many ways. You feel that what I would summarize, based on your presentation, is less space usage and perhaps a more consistent model is the benefits.
More consistent model in many ways, and in terms of the implementation, it's more consistent. So one of the issues that open config models have today is that they're not strictly compliant with Yang, for example. The case in point would be if you had a system created interface, then technically in Yang, you're not allowed to have that in the open config models, because you're creating config nodes to represent a state object. And they bend the rules a little bit with how they do that and say, well, it's okay, if you only create the leaves in the config space, then it's not really configuration, it's actually operational state. So all the open config models aren't quite following the Yang rules. And there's other things that they can't do, like they can't make use of choice statements, they can't make use of presence containers, because they don't really work in the open config style. So it's not just it being a bit cleaner. I think there's other things that we've noticed and through this whole process and said, no, this is the best technical solution.
So a third thing would be perhaps the tool chains will be easier to support your Yang models given this better usage of Yang. Thank you.
I think so.
Thank you.
I see.
AC Lynn, just as a data point, we kind of did a survey and we didn't have of the IETF OSPF model, and we only had one implementation, and that implementation didn't care if we changed it. And the size of the model was more than a third reduced when we went to the NDMA standards. And we also asked the implementers, are there many, at least for OSPF, there weren't many cases where the intended and applied, or there weren't any, where they were going to deliver different values of the config. So it was sort of the benefit of a pretty greenfield for OSPF. For OSPF, it definitely cut it down significantly.
John Messenger, just to note that another advantage of this style is that it's more maintainable because there's less duplication and therefore less room for error. Thank you.
Benoit Claes. So Rob, I was hoping that during your presentation you would explain the tooling that you've been working on and actually how you could help people moving from one to an MDA. Can you say a few words about that?
Yes, I can do. So I'll just quickly answer that now. So I've been looking at some PyAM plugins to help this process in various different ways. So the easiest one to come onto, or I'll come later, is to create an extra state tree where necessary. That can be done by hand quite easily, but I have some tooling that does that. The other one I've been using with some success is one that takes the existing IETF split style and has a go at generating the combined tree. So it's not perfect in terms of it doesn't do everything for you, but it does help you go along the way, and it puts in comments as to where you need to do that. I need to check how well that works with some of the grouping models, but that's what I use when I was looking at the routing ones. So
it would be great if you could document this and post this on the mailing list to help people.
Yes. Yep.
So Ilya Atlas. So one thing I'd like to emphasize here is when we're talking about this, this is, there's a lot of good reasons to do this. The meat of the model, the complexity, the pieces that folks have been working on is all about the abstractions and the information model and what you're doing. On some level, this is the presentation layer impact on top of the meat of the model. And so when you look at the difference between the models, it may be like, wow, this is really different, but it's a presentation style difference, not a content style difference. I think that's important to think about when you're looking at what the change is. As Rob said, you can do a lot of this very programmatically, and he's working on tools for that. And so I know the models may look like they change a fair amount, but it's presentation layer, it's not content.
Hello, Igor Briskin, Huawei. Working on T-tunnel model, we discovered that OpenConfig style is actually quite awkward when you want to create groupings and reuse the groupings in someplace else. For example, if you want to take a piece of, say, a tree and use it as RPC input and output, having config state everywhere, it becomes very awkward. Okay, so the MDS die actually solves this quite nicely.
Thank you. Oh, we got what?
Continue.
So this is more some questions that just have come up, and I thought would be useful to answer effectively. And the question is, can we use the NMDA style modules on existing netconf RESTconf? I.e., do you have to wait for the updated netconf and RESTconf? And I think Lou sort of answered this in his presentation as well. It's the same sort of comments is, yes, you can, but there's no way of representing the applied configuration value. And when AC spoke about the OSPF model there, he said, well, actually, that's okay. For their model, it doesn't actually matter. The operator that they were speaking to doesn't care. You wouldn't actually have any differentiation between the intended configuration value and what's been applied. And the other case where it doesn't work on existing devices, but will when you have the operational state data store, is it can't represent system-created configurable objects. So it can't represent an interface that exists because a line card's been plugged in and the system automatically creates it, or a default system interface like a loopback 0 that aren't actually configured. Because effectively you're creating config entries for those. So that's the two cases where an NMDA style model doesn't work with existing netconf and RESTconf. Obviously, when you get to ones that support an operational state data store, both of these are supported fine. Most modules, this isn't an issue. The ones where it is like interfaces and ones that augment interfaces, well, that's okay because they've already got a split today. And although we'll be updating those to be NMDA compliant, the interface's straight state tree will effectively end up being deprecated but still there. And in the cases where this is a problem, then there's a fairly easy mitigation around that, and that is you create an extra for your foo module, a foo-state module. And that can be almost a straight copy of that module, but with the name changed to state at the top, which puts in a different namespace. All the nodes inside it go to a different namespace, and you put a config false at the top of that tree, and it contains the same contents. And the last one is you want to reuse type def. So effectively, it's very easy to generate this. I've got tooling that has a go because it's simple to do. And that can be put into the draft appendix and used as a transition module effectively at the time until you've got an NDA compliant stuff available. And the expectation is that gets obsoleted over time. But I would stress that it's worth only creating these extra state modules when you need them. If there's not a requirement, it's better not to do it rather than putting them in just in case. Chris
Hobbs. I know that the work is being done in NetConf to support this, like with new RVC. I don't follow the RESTconf very close. Is it being worked on parallel on RESTconf?
Yes.
Okay. So is there a solution proposed and ready to go?
Yes, yeah, I think so.
Awesome.
Jeffrey?
Hi, this is Yufeng Liu from Jibo. I agree with everything you say here, except that qualify, you say small number of cases, but I would say it's not that small number, so quite a bit numbers.
Okay, it depends. It depends. In those cases that's required, that's fine. So the final summary is that I would like, ideally, all IETF modules to move to this style, because I think it's the right answer for the future, and I think the consistency is really important, personally. As I've said here, you can generate this extra state module even when it's required, but we're asking you not to put it in just automatically. They have a think first as to whether you really want it. If you've got any further questions this week, then myself or any of the authors will be happy to speak to you and talk to you about it. And there's various aliases you can contact that. And the tooling that I'm working on, I'll try and send out details of that as well to help folks as they migrate towards these modules. Okay, thank you.
Thank you very much, Rob, for coming here and presenting. So we'll keep on guiding and supporting you on progression, how to move from your existing model towards NBMA. May have any requests, please send it to routing working group as well. We'll invite Rob again for the IETF 100 to explain in more details how to do it. So it's not only theoretical presentation, but real use cases and how we do it. Thank you.
Good morning. I'm Fang Wei from ZTE. So my topic is young data model of control plane and user plane separation of BNG.
Good look.
So this is the background of VBNG. And in the left picture, this is the traditional BNG scenario. BNG is the gateway for the dialing up user traffic. So there are 3 pain points, I think, from this traditional BNG scenario. The first is that services are not well balanced in different paths. The second is that BNG acts as both for the forwarding function and the controlling function. Both of the forwarding function and the controller function can be the bottleneck of BNG device. So BNG maybe have very heavy, will become very heavy. So
I want to interrupt for a moment.
Just a quick clarification. AC Linda, I haven't read the draft, but is user plane the same as the data plane in this context?
I will introduce in the next slide. Oh, so the third pain point of the traditional BNG is that the BNG are configured on each device. So we think that is not very convenient or management. So here this is the scenario. Sorry. So we wanted the BNG to be virtualization, and so BNG can be submitted into BNG CP and BNG UP. Here, BNG CP is a user control and management component. So BNG CP can be implemented in the server or the hypervisor or VM. And the BNG UP, we name it as the user plane. It's for the network edge and the user policy. And so BNG UP is used for the data forwarding. So we name this architecture as the VBNG. Next, so I will try to answer your question. So here we can say that BNG UP is used for the forwarding for the user data forwarding, and for the dialing up of traffic, you can see the red line. The dialing up of traffic will forward from BNG UP to the BNG CP. Yeah. So so I think the user panel is different from the data panel here.
AC again. So it would really be the setup, the setup of the data plane, like the subscriber policies and circuits in the user plane. That as opposed to the actual, it's the setup as opposed to the actual traffic. That'd be a good way to characterize it, right?
So, how to answer? So, so the dining up traffic will be terminated in the BNG CP. For the user traffic, we're forwarding from BGP, BNG UP to the other core network or in the network. Yeah. So here there are three interfaces between BNG CP and BNG UP. And the first interface is the service interface. And the service interface is used to establish VXLAN tunnel between CP and UP. Here, the VXLAN tunnel is used to transmit the PPOE or IPOE packet from UP to CP. And the second interface is the control interface. The CP uses the control interface to deliver the service entries. For example, the routine entry or COS, the COS policy from CP to UP. And also the UP use control interface to report the service event to CP. So this is the function of control interface. And the third interface is the management interface. So the CP uses this interface to configure the
You
UP.
put 8 slides, a lot of information.
Yeah.
You run out of time.
Okay, thank you. So I will quickly. So here we have several drafts to address the VBNG topic. So we have the architecture and the use case draft. It submitted to NFA-RG. So and also we have the VXLAN intention for the service interface and the information model for in the I2S work group. So this draft we define the management interface here. Yeah. So this is the configuration of the VBNG. The VBNG is based on the logic network element. So we augment logic network element. We define the VBNG name and the enable switch in the VBNG model. And here we define the interface of the VBNG and also the sub interface and the open flow channel. Yeah. And the VXLAN channel and also ACR and COS. For the open flow channel, we will define the open flow name and the DPID and open flow port. VXLAN channel, we will define the VXLAN tunnel ID, VXLAN tunnel name, and the tunnel source IP and the tunnel destination IP and the VXLAN ID. And for the ACR and the COS, we will augment the existing young data model from other draft. So yeah, comments are welcome. So is there anyone has the interest to work together? No comments. Okay, thank you.
I guess I have a little bit of comment on the terminology that AC was asking about. Maybe something like subscriber aware or user aware data plane would sort of describe the user plane well, because it's data, but it's also subscriber aware because it has per subscriber policies and so on. So I'm not sure.
Yeah. So do you think that the subscriber traffic belong to the data panel? Data panel. I think the the data traffic is between the ORT to BNG app and the core network. And for the subscriber traffic, we send from BNG UP to the BNG CP. So I'm not sure this traffic is belong to the data plane or control plane.
Just quickly, AC, this looks like something, I don't think it belongs in this working group. It's either someplace in INT or the broadband forum.
Yeah, I know that the BBF also have to do some work, but here we wanted to define the service interface because we extend the VXLAN protocol, and we also that we can define the management interface because we use the young data model. Yeah, I know that BBF has the architecture.
Yes, so BBF is working on the BNG architecture indeed, and there's also some work done together with 3GPP on alignment, user plane, control plane separation. So you might want to work. And
yeah, I don't attend the BBF. Thank you.
Lou Berger. The interesting thing about this is it sort of parallels the work that's being done in TEAS and CCAMP with ACTN, where we're doing controller-based models for control of traffic engineered network. The big difference here is this isn't traffic engineering, but it's the same type of idea. So I don't know if it's worth talking with, maybe you want to talk with the ACTN authors a little bit and see where it fits in with their work. I don't think it's right for TEAS, but that doesn't mean it may not fit in somewhere.
Oh, I'm not familiar with ACTN, so I will try to discuss with the guy from.
Yeah, there's
ACTN.
a bunch of the ACTN authors are in the room, so I'm sure they'll come up and talk to you about it.
Okay.
Yeah, again, the big difference is ACTN's really been focused on traffic engineered network, where this is not.
Yeah. We BNG doesn't care about the traffic engineer. Yeah. Okay.
Thank you, Ahmed.
Just click this one, right?
Yep.
Hi, good morning. My name is Ahmed Bashandi. I will be giving an update on the TILFA and the micro-loop avoidance drafts. First, a brief refresh of the draft. So, segment routing based TILFA is really for local protection. The objective is to provide topology independent in the sense that if your hardware is capable, then we'll give you the protection that you want. It is based on segment routing, and it provides protection for both prefixes and adjacencies. There are already implementations that are out there. The idea is, or what is really important here, is that the FRR path actually is over the post-convergence path, which means it's utilizes the ECMP. It uses already the metrics or the capacity plan metrics to help for that. Question? Yes.
So could you go back one slide, Chris Bowers?
Yes.
So why does the draft restrict the SRLG protection to local SRLGs?
At this point in time, the algorithms that we have work on the local SRLG. However, the idea of constructing a label stack can work, or actually a SID, to be more specific, a SID list can work for any kind of failure, local or remote.
But in terms of a working group document, I mean, are you describing the algorithms in enough detail to actually sort of limit this document to just local SRLGs? Why wouldn't the document at least discuss remote SRLGs as well?
You probably, at this point in time, the plan that we have in mind is to restrict it to SRLG protection, but in future versions, if we think it is relevant or we think we have algorithms that we're willing to expose, we'll just add it there.
So this seems...
I have to scope it to something.
Okay, well, I would suggest adding remote SRLGs as well. It's a artificial scoping in this case.
No, it is not. The algorithms are quite different.
I understand very well about these algorithms.
Right.
And okay, if you, so I guess I would suggest adding remote SRLGs, but we could handle it another way.
Yeah, the algorithms are quite different. If they are similar, then you're probably right, but the algorithms, as you probably know this, they're quite different. So, which makes the scope of this draft much bigger, and
Okay.
will add to the future.
So you specifically don't want to cover that, and
Right.
so-
At least not in this version of the draft. Maybe in the next few versions, we can decide otherwise.
Okay, thanks.
Thanks. So the idea is to force the traffic over the post-convergence path to make sure that there is no risk of failure, or there is no risk of the packet being looped back. This actually idea works for both MPLS forwarding plane as well as SRv6 forwarding plane.
I would keep IPv6 out of the discussion, right? You know, there's discussion going 6-man and.
Okay. That's. So how many segments? If you have symmetric metrics and you want to protect links only, you're guaranteed to need at most 2 segments. In most scenarios, based on the simulation that we did, 1 is enough. If you're one of your neighbors or your new next hop is a loop-free alternative, then you don't need any segments. You don't need to do anything. Just send it to the new next hop, and it won't bounce the packet back to you. For asymmetric links, if you want to do link protection only, in most cases 2 would be enough. There are a few cases where you need more than this. For node and SRLG protection, and as Chris pointed out, I'm restricting it to locals for mathematical and technical reasons. In most cases, 4 is more than is enough. In most cases, I'm saying 4 is more than enough. Usually 2 is sufficient, but we can always cook up scenarios that you need more than this. Update on the commands. So important command IPR disclosure, we will make sure that they are taken care of. The draft is specific to SR. There were commands saying, why don't you use other methods? Sure, I mean, we're not saying otherwise, but we're restricting this to segment routing only. The draft protects shortest paths, which means if somebody has a very specific winding path, and to be very specific, and is not using segment routing. So if I am using a stack of segment routing, an explicit path that consists of a list of adjacency SID and node SIDs, in reality, we can do protection for that. Last comment were for security consideration. So the draft actually says, makes sure that the traffic goes over the new post-convergence path very quickly. So you can think of this as kind of like a modest security enhancement rather than a risk.
So a couple of things I don't remember seeing, Stuart Bryant, a couple of things I don't remember seeing in the draft is text on abandoning the mechanism when the constraints aren't met.
So that's an implementation detail. So if I have a feature,
that's not an implementation detail,
It is.
because you may have to signal to other devices that it can't be met.
No, I have configured my router to do link protection only, and I don't have to tell other routers anything. Why do I have to tell the router that I'm doing link protection for this prefix?
No, remember when I talk about when the conditions aren't met, it means that maybe you're not able to push the right number of labels, for example, or you were set up for link and actually you saw a node.
Again,
because other routers are going to try and do the post-convergence stuff and the loop avoidance, and they may not be able to do it.
Why would, if I cannot do link protection, why wouldn't other routers be able to do micro loop protection? I don't see the relation between them. What, okay, first of all, this is a local behavior, and the fact that other routers know or do not know that I can do it is totally irrelevant to anything else. I fail to see why you think there is a relation between them.
So it's the loop-free convergence process that happens afterwards that where it becomes interesting, because what you do is you push in your your repair if you can obey if you can cope with the constraints that you've just discovered, which may escalate as you as you discover more information. So, for example, you could be set up for a link and then discover it's actually a node.
Okay, then I don't protect it because I can only do links.
Right, so you should immediately abandon all other processing and go straight to best effort convergence.
Okay, maybe there is a misconception here. We do the best effort convergence. It is there, except because somebody configured this router to do TILFA, he will do the TILFA. Okay.
Right.
If after a while he discovers that he needs to do that this was a node protection rather than a link, he can download the regular path, which is already calculated.
Right, but with the
why do I have to signal anybody else? This is the whole
certainly
point.
the text needs to discuss this.
Why? This is an implementation detail. I mean, I'm set up to run BGP and suddenly I need to run OSPF. Why do I need to tell everybody that I'm not going to run?
No, I don't think it is an implementation detail. Okay. You have to describe to people the process that you're going to run, because not everyone will work out the subtleties, right? So this is not about hiding information. It's about describing what you really want people to do. But the second point is to do with, you then go into loop avoidance. Loop avoidance takes time. And so you have to abandon loop avoidance, which other people are helping you with.
Why? Okay, loop avoidance is a local behavior that says irrespective of what happens downstream, it works. So whether the downstream router decides to do TILFA or not, it still works.
Oh, Atlas, no hats this time. Okay. But I've thought a little bit about fast reroute, of course. Look, if you have a worse failure so that your failure assumption doesn't hold, you get loops. And the rest of the network, if you're trying to do, particularly for anything like this, which is more sophisticated than LFA, what you find when you do remote mechanisms is you want to also do micro-forwarding loop avoidance, right? And that assumes that the node at the point of local failure is doing a local repair and continues to hold that repair while the reconvergence happens elsewhere. And if you're trying to do the micro loop forwarding avoidance, and if the point of local repair is not holding a repair because a worse failure happened, then you also want to terminate the micro loop forwarding prevention and go back to let's just converge as fast as possible. And therefore, it is not local behavior.
Okay. Let me reply to this. First of all, the assumption that micro loop avoidance requires the node attached to the failure to do something is wrong. I do not care about what the node attached to the failure do. Whether it does TILFA or not, it works. Micro loop avoidance works.
Let me...
Number one. Second thing.
Can I interrupt for 1 second?
Yes.
This is Chris over here, the chair. So you're presenting also on a micro loop avoidance technique.
Yes.
That particular micro loop avoidance technique does not require that.
Yes.
However, in general, other micro loop avoidance techniques do require that. And Aaliyah's point about worse than expected failure cases, I think always holds. That
maybe I am restricted. That's why I said at the beginning, and I tried to make it as clear as I can. I said SR, TILFA. I always say segment routing, segment routing. If you want to mix and match techniques, you're on your own. Okay, this is segment routing. It's a complete architecture. It works.
So I think the fact that the two of us are confused would suggest that we need more text in this document to explain to those of us who
I can
experience
add,
in this space.
I can add segment routing 10 times or 100 times in the draft, but I think one is enough in the title. It says segment routing. Okay.
So you cannot simply say the microloop avoidance draft forms part of your microloop avoidance draft forms part of a particular architecture that only this works for. I mean, if that's the case, you need to state that very specifically.
Oh, okay. I mean, the title of the draft is microloop avoidance uses segment routing. I'm not sure how specific can I be more than this.
Well, even segment routing's only got partially strict routing.
So right now we are talking about the TILFA draft.
Right. It says here SR. I mean, the title is called segment routing. I mentioned it multiple times. I don't know how many times more I should mention it. Other techniques are beyond the scope of this.
We're asking for text that talks about the interaction of it with micro-forwarding loop avoidance and under what circumstances you need to bail to best effort instead of because you've had a worst failure. And there are multiple reasons for that. One is because it doesn't have to be just local behavior. Two is because we are trying to write specifications that people who are not here can actually go and implement, and they may not have all of the understanding. And because if you get it wrong, you loop traffic.
So
thank you.
The reply to that, again, as I mentioned, the implementation of this technique is specific to certain failure. If you have more failures, then it is really the implementation problem. You cannot ask me if I say I am giving you a standard for OSPF, what happens if somebody beside you uses ISS? Well, too bad, I don't know.
Well, we disagree, and I guess we'll continue the discussion as the draft progresses. But I'd like to ask another question, which is to do with this is all about forcing the traffic onto the post-convergence path from the PLR.
Right.
But in fact, a lot of traffic will never go near there after the failure.
True.
And so I think I keep finding it hard to get in my head what is actually going to really happen in a real network, as opposed to this hypothetical one that continues to send stuff via the PLR.
So if the road from here to there fails and use another road, what do you want me to do, right? Say, what else you want me to do? I don't see what is the concern here. So yes, traffic will move to somewhere else, great. What is wrong there?
Well, there are two concerns. One, that you might not have the bandwidth if, forcing it via that.
No, I will only force traffic if it comes to me over the post-convergence path from me to others. If it doesn't come to me, I cannot do anything to it if it comes over there. I still don't understand what is this concern. I read this multiple times. I said, okay, what is the concern?
If I may summarize, all the requests have been made from Stuart, from Ali, as working group participants. There's definitely clarity needed in the text of the draft, and they ask you to review the text, and if needed, if you feel it's not clarified enough, besides the name of the draft, provide more text. I think
I will add segment routing in 4, 5, 10 places in the draft. I think
it's not about segment routing, it's about explanation, and questions have been asked.
Oh, okay, the question is whether I will write a statement say I will only protect traffic that comes with the PLR. It seems quite obvious to me, but if a statement like this is what is needed, I can add it.
So that wasn't the only statement.
The third statement is that what happens if you have a worse failure, and what I said is that this is beyond the scope
So
because
add text to
texting
explain this so that
okay.
these experts on this topic can understand what you're proposing.
Okay, I'll add a statement. This is, for me, it's redundant, and it's one probably 10 words. I'll add them. For me, it feels quite obvious. Anyway. We are, okay. Next, we're ready for working group adoption.
Can I actually go back a slide, please?
Sure.
So you mentioned an IPR disclosure?
Yeah, this will do. Will do.
So you still need to do that?
Yes.
Okay, so we're going to go through the IPR disclosure process and, questions and so on before working group adoption.
I believe you asked for the IPR disclosure during the working group.
Occasionally we do that. However, our general rule is to ask for it before.
Okay, go ahead. No, okay. I mean, how do you want to start this? Like send an email or something like that?
We'll send an email. asking
Okay,
for it.
yeah, please. Please go ahead.
Tell us when you have actually disclosed the IPR. Have you disclosed the IPR? Is there more
There
IPR
was
to be
one
disclosed?
for the previous version of this one. The previous version under Pierre Francois' name. There was one in it. Then this one replaces Pierre Francois.
Okay. So you've already disclosed all the IPR.
Probably. I will check. I have to look. This has been like almost a year
No, no,
ago.
it's up to him to decide. So.
Yeah. Okay.
Okay. So, anyways, take care of that. So when we ask the question to the working group, everyone, authors and so on, can respond,
Right.
and previous authors can respond about the IPR.
They are the same author, except that the name Pierre is still the author. Just that I'm
Okay,
taking care of it
that's
now.
fine.
So pretty much the IPR disclosure seems like the most important, which is an important concern. Go ahead.
Oh, yeah, Atlas. There are no IPR disclosures yet on this draft.
Okay.
It's been over a year. Please read the note well and stuff, because the point is not to disclose IPR when you're asking for working group adoption. The point is to disclose it beforehand as soon as possible, at the earliest point, not at the latest point. Thank you.
What happened?
Just continue. Oh, sorry.
Something happened. Okay. The next one is the microloop avoidance. Again, brief memory refresh. It occurs if a router downstream on the new path has not yet converged or has not yet programmed its forwarding plane and may end up bouncing the packet back to you, whether directly or through an ACMP path. We're restricting it to segment routing. Okay. The primary difference is that between TILFA and microloop avoidance is that TILFA works for local failures that are detectable at the point of local repair. Microloop avoidance protects against loops that occur due to a remote topology change, whether it's a link up or a link down. The objective is to make sure that traffic goes over the post-convergence path, irrespective of whether routers downstream on the new post-convergence path have converged or not. So whether they have converged, they are using some TILFA mechanism, I don't care, using microloop avoidance themselves, it doesn't matter, it'll still work. Here is the idea. So router B, the one in blue, previously it used to send traffic down towards the down direction, towards PE2, but the link AD has failed. So what it does is that it sends the packet over the green path at the top. If C has not yet converged, then C will bounce the packet back to B, saying, well, why are you sending the traffic to me? You're the shortest path. So the way it does is that B will tell C, send the traffic to E, and once the traffic arrives to E, the shortest path from E to PE2 is via the post-convergence path. It's pretty much very similar, but not identical to the to TILFA mechanism. Again, similar to TILFA, it doesn't matter what happens downstream, whether they converge or not, whether they're using TILFA or not, it doesn't matter. Idea is the same. You detect the topology change. You detect that there is a risk of loop. So you explicitly forward the traffic over the post-convergence path using one or more list of SIDs. After a short while, you basically use the normal path without adding any SIDs to it. The amount of time that you wait, there are many ways to do that. One of them via protocols that are proposed, others via configuration, other via testing. The determination of this time period is not really in the scope of this draft. How many segments? If you can look at it, it's very similar actually to TILFA, so symmetric links, maximum 2, most often 1. In asymmetric topologies, I can cook up an asymmetric links in topologies with asymmetric link. There will be cases where I can cook up topologies where you need more than 2 SIDs. For the link up scenario, it is guaranteed to be 2. It doesn't matter whether it is symmetric, asymmetric, it doesn't matter. Again, update on the comments. IPR disclosure will be made. Thanks. or a few nits, like I think some, thanks a lot, like typos and a few things. What topology changes are covered at this point in time? We're restricting it to link and node up and down events. In the future, we may restrict it even more, depending on the algorithms. How to determine the time period between stage 1, which is where the traffic is explicitly forwarded over the post-convergence path, versus moving to stage 2, where the traffic is just forward classically, just send it to the next hop, to the new next hop. There are many ways to do that: configuration protocol-based, simulation-based, really off the topic. Security consideration, same thing. This mechanism ensures faster ways of sending the traffic over the post-convergence path without risking loops. So you can think of it as a minor security enhancement. Oops. And we're ready for working group avoidance adoption after we do the IPR disclosure. Any questions?
That wins the Freudian slip of the year here.
Any question? Yeah. The thing is,
Oli Atlas, for the link down case, how do you tell what kind of a failure has happened to know what the post-convergence path is?
Again, this is configuration driven. You come and tell me, do link protection. Okay, so I will do link protection. You come and tell me, do node protection. I will do node protection. It is not that I know that through some funny mechanism, because it's really impossible. It's the other way around.
I was thinking more about local SRLG. So what you're actually going to is the post-convergence path if the worst case failure were to happen.
No, I would say this is configuration or policy driven. You tell me what you want. I don't assume always that it is node if I can do node. I don't do that.
So what you're doing is you're finding the post-convergence path for the configured worst case failure.
Right, yes.
And what are the termination, do you have the termination conditions in there in case the failure that actually happened is different?
Again, this is the human that said, do this, I will not do something else. It's his business.
Thank you.
Chris Bowers, could you go back a couple of slides? Do you take into account SRLGs in this case?
I think for this version we don't.
You're saying this version of the draft?
For this version of the draft, for the micro-loop avoidance, because it's a little bit harder to do that, because failures are remote. And for link up, it's even tougher, because when the link comes up, well, I don't know what others would happen. So for SRLG, I don't think we're taking care of that. I wrote this draft a long while ago, so I don't remember, but I don't think we're taking care for micro-loop avoidance of SRLGs.
Okay. So for both this draft and the previous draft, you've explained that, remote SRLGs cause problems, so it's being left out. I think you should explicitly state why you're leaving it out. Otherwise, it's an obvious question that comes to one's mind.
No, because this means I have to state the problem that is really I'm not addressing in this draft. Otherwise, and if you think about it, I have to go over all problems in the world and discuss.
No, that's ridiculous. So the local if you said I'm not going to address SRLGs, period, then okay, fine. But you should state that as well. I mean, node protection itself is a form of SRLG.
True.
Okay, so once you are in this protection topic, SRLGs is obvious. You're talking about local SRLGs.
Yes.
An explanation of why you restrict this to local as opposed to arbitrary SRLGs is completely appropriate for a document that you expect the working group to adopt.
I tend to disagree. However, even if it is, I am restricting it to a certain problem, and I don't have to explain why I'm not addressing other problems.
Well, you may do, because it depends on what the discussion on the list is. Now, I'd like to bring up another sort of topic, which is something that's always puzzled me when we do fast reroute in a segment routing environment, and that is presumably we routed the packets through a number of hops for a particular reason. So presumably we need to apply the same policy that was applied to those selections in the selection of the alternate route. For example, if the original policy was set up to avoid going over a particular link for example, a security reason, you want to make sure that your fast reroute doesn't avoid those policies. So I think there needs to be some discussion about policy, which wouldn't normally apply in a pure best effort network.
Okay, I think I've mentioned this many times, but I can mention them more. This draft protects, in the third bullet, protects normal shortest path as calculated by IGP as well as EdgeSet. I'm not sure how many times I have to repeat this. I said this on the mailing list multiple times. I wrote it in a draft, and I wrote it right here. Okay.
Hannes Gredler. Ahmed, you are overselling here. You're saying topology independent, right? But effectively what you're doing is not so topology independent. And that is by carefully escaping out anywhere where it gets difficult.
Maybe you're missing the point. Topology independent, it doesn't matter how things are connected to, I will protect shortest path. So that's why it's called topology. The definition of topology is what is connectivity, right? So what I'm saying here, it doesn't matter how your network is stitched together, I will give you protection.
Yeah, and then there's a couple of SRLGs that you seem not to consider. So what you're saying here is not independent, right? You are assuming an overly idealistic model, which does not reflect much of reality here.
No, topology is connectivity, and I can bring out the mathematical definition. It's connectivity, and I will give you protection in whatever things are connected to. Okay. What you're saying is that even though these two are connected, but they will fail together. That's a failure scenario. So if there is a failure scenario where two links will fail together. I agree that I'm not covering this particular failure scenario.
Practical failure scenario.
We can disagree on that. However, the term topology is correct. That's a different topic. We can go there. What I'm saying is that I am restricting the protection for certain failure scenarios on any topology. Clear?
No, it's not any. Thank you.
So let's take it to the list, and I assume you need to do a lot of clarification because before we can progress.
Okay. Any other question? Okay.
Thank you.
Thank you very much.
Tony.
Good morning, everyone. Nice and jet lagged, I assume. Monday. No. This will be a very boring presentation. The mention of Yang anywhere, so no contention.
Did you do Yang?
It's not clear to me that the clicker is going to work with PDF, so.
Okay. Yeah, you should have told me. Okay, yeah. I mean, it's not that much material. So yeah. You should have told me, otherwise I would have sent you PowerPoint. You want the PowerPoint quickly on a stick? Oh.
Go back. Yeah.
That's good enough. Can you go to title slide, please? Oh, cool.
Yeah, it works.
Oh, it's working. Cool. Thanks. See? So we're fully automated. All right, so I'm giving an update on the Rift draft, what happened between 102, quite significant stuff. New co-author, Comcast. We worked on some real-world experience, tons of industry input, and what happened was, what happened was roughly that. We extended the requirements, but one or two things which have proven important to some customers. Some customers insist and run east-west link, so we added the list east-west link procedures. I mentioned the work. We had interesting operational discussion about internal reachability of nodes within the fabric in all kind of failure scenarios. So we added considerations for that. Some people desired better description of the flooding scopes, so we wrote the rules down more carefully. The default origination procedures are non-trivial, so we spelled it out better. We added BFD interactions optionally, which are also desired by some people. Some of the encoding has been changed for better implementation, and the section has been added that deals with topologies which are not strict clause, because people have some ideas. They don't have deployments, but they have ideas. All right, so what happened in terms of requirements? So it looks like people are not overly happy with LAC and MC LAC, layer 2 in IP fabrics for multiple reasons. I mean, some of them. There's always people who are happy and some people who are unhappy. So we added mechanism in Rift where basically you can replace LAC for all practical purposes with Rift. So and you can run it, of course, on links which are non-uniquely addressed or are unnumbered. So we can support unnumbered parallel links and basically provide a full LAC functionality. The MCLAC discussion, we don't want to touch the stuff in Rift. MCLAC is pretty much IP multi-homing, or otherwise it's really an L2 problem. And it's an ugly problem because it's not really a standardized problem in terms of multi-share select synchronization. After discussion, looks like we don't need any kind of forwarding adjacency support. We just use tunnels as interfaces, and there's no further considerations needed. Next time I'll probably show something. People are very interested in an optional mode where basically the whole data center configuration will be brought down to almost zero touch, right? So with very minimal amount of configuration, you can bring up the whole data centers fully configured. So how do the optional east-west procedures work? Little picture. If you imagine, so I show you an A and B, the blue ones is a pod and Z is another pod, and the 10 and 20 are leaves, and alpha is a spine switch. If you have a node-bound failure between A and alpha, that is where normally you would start black holing, right? So we do the full deaggregation and so on. Without east-west links, Rift works. But people desire to use the east-west link. So we have optional procedures where A can use the east-west link towards B in case it gets traffic from 10. So 10 to A will go to B, and then it will go through the spine alpha to go to 20. The traffic is asymmetric because when 20 sends traffic back to 10, it can obviously not go through A. So it will always go through B. But that way you can use the east-west links in case of failures, basically to protect a layer against node-bound failures when you lose node-bound connectivity. That is still completely loop-free, which is very important. So it's not generalized routing, right? The east-west will not be used in both directions, because then algorithmically, the whole thing deteriorates into generic link state routing, and Rift has absolutely no purpose. You can run ISIs because all kind of funky topologies get constructed where all these links starts to forward bidirectionally in the east-west direction. Okay. So on the internal node reachability in terms of all kind of funky failures, right? We added a new section, and basically what we recommend is that the internal node injects its loopback address into the node-bound direction, which basically, without failures, allows you to reach this node internally, either from south or from north, okay? The interesting things happen is when nodes lose node-bound connectivity. You have to think that through what happens, but basically the node may become unreachable from certain nodes. So what we recommend is that in such scenarios, the nodes inject south PGP ties, their loopbacks, which makes them reachable again, at least from the south. So that merits maybe further consideration, but we thought that through and there's a section dealing with those failures. The precise default origination procedures in the southbound direction has been written down, so it's not entirely trivial. I pretty much spelled out the rules. I don't think on the fly it makes a lot of sense to go precisely through them what they mean, but I put them nevertheless into the material so people have something to refer to. So a node will inject a default under certain conditions, right? Because in other conditions, the default injection would just lead to black holing, which makes no sense. The BFD interactions are relatively easy. So we allow, or optionally, it is just fine to run BFD on the same links as Rift, right? And we just specify the interaction that you bring BFD after the Rift brought the three-way, and the BFD after it came up and goes down can bring the stuff down. So to prevent all these admin down problems that other protocols have. We align the link IDs, which is basically a unique identification of a link in Rift, with BFD discriminators, so implementations can very easily basically reuse the values if that makes any sense. And the BFD may be used on subset of links, on all the links, in terms of like having a micro lag all of a sudden, right? Micro BFD running over a lag. And ultimately, based on experience, the encoding has been changed. What it means in Thrift terms is that a lot of sets have been replaced with maps, so implementation get much faster. Look for elements within the encoding much faster when certain information elements have to be accessed. And that's about it. I'm surely under time.
Greg Mirsky, can we go back to the BFD slide?
Yes, sir.
Thank you. So when BFD, you refer to single hop BFD.
Yeah, nothing else. Rift is a link, no, hop by hop protocol.
Okay.
There's no multi-hop Rift. I mean, we talked through these issues. There's simply no application for it. You run tunnels if you need that, and then you run BFD over tunnels or whatever you do.
Okay, so basically you make explicit that this is only single hop BFD.
Possibly not, but I should. I think I refer to the right drafts. I don't refer to the multi-hop BFD, but I can look it up. Yes, but that's the idea. Really trivial. Basically, it's a trade-off between having a control plane which can pump the hellos fast enough to keep you happy at a certain point in time, to having to go to timer resolution where it doesn't make any sense to run the control plane. So please invite your hardware, which for practical purposes means BFD. The problem has been solved well in BFD.
What I'm interested, because I had the discussions with some data center architects, and they believe that with the current hardware, you don't even need single hop BFD because your hardware works loss of light even faster than any fast BFD.
Yeah, and we know it's not true from a lot of interesting laser deterioration problems and so on.
No,
right?
it's you basically what your interest in BFD is very interesting to me, because it's a argument in this discussion.
But look, I mean, we went through the curve for 20 years. We know the loss of light is not good enough, right? BFD has a purpose, has been built for a very specific purpose, and is very widely used. Now, if loss of light would have been good enough, BFD wouldn't have existed, right? We have MTU problems, we have single no direction connectivity problems, we have all kind of weird stuff. And BFD is doing an excellent job.
Right.
Hey, Cylinder, I did read the draft. So in this change...
Why do you point it out so specifically?
Oh, yeah, well...
yeah, all right, sorry. Yeah, just a pun.
Yeah. For the self-bound ties, this change, so you always flood your self-originated S ties.
Correct, unless you're a leaf and you don't follow leaf procedures.
Right.
Yeah.
So what happens is now at any level, you'll also inject a prefix tie for your loop back. Is that all the time, or only if that node loses its northbound connectivity.
Very good. Yeah. So in the north direction, we recommend you always inject, right? Because that's how you reach the node without any failures. In case you lost northbound connectivity, you may not be able to get to it. So we recommend that you inject an SPGP loopback prefix, which will make you always reachable, at least from the southbound direction. The problem is ugly, and the problem is very real today, from what I understand.
Now, for the purposes of flooding and injection, I noticed you pointed out that you don't use your east-west ties, east-west links, except in the failure, if you lose your north.
No. The southbound flooding is equivalent to east-west flooding.
Yes,
So
right.
Okay, good.
So that happens automatically because that's always a longer path because of the SPF.
Correct.
Unless there's a failure, right?
Correct.
Yes.
Yes. Okay. Yeah. I know it's very non-trivial, pretty deep, yeah, but it's precisely why it has been built that way, yes. So you read the draft, good.
Thank you, Tony.
All right, excellent. Thank you very much for your attention. Later.
Russ White.
It's gonna make me stand in this little pink box. He knows how much I hate that. Russ White, LinkedIn. That is Tony P's data center. Sorry. This is ISIS support for Open Fabric. It's pretty much the same presentation I gave last year, except there are a couple of small changes. Oh, look, I don't have to look behind me. That's amazing. Anyway, a couple of small changes in the encoding and stuff like that. Essentially, the idea behind Open Fabric is to split the policy from the reachability in to make things much, much simpler. This is trying to just simplify ISIS or using ISIS as a base and simplify things so that things are a lot easier to manage. Simplest possible distributed link state protocol, no policy in the protocol, no configuration. Essentially what we're trying to get to is having no configuration on the boxes. Everything just comes up and boots and it just works. No extra stuff. Trying to keep out of the feature creep realm. Running a big data center and you get lots of features and basically the features just become node knobs and the node knobs just become weeds and you end up spending a lot of time trying to weed your data center fabric and it's really ugly. There's a loose feature set right now. Eric Osborne observed to me in a private email exchange. I don't know if Eric is here. I don't think he is this week. But anyway, that there's a lot of may remove features. This is something we need to look at as authors and contributors and figure out, like, should we tighten that up and make some things may be not included, some things must not be included for interoperability. This is just something that was brought up in the last week. So something we need to look at. If you have concerns or feedback on that, I would like to hear those. Basically, the draft lays out in several small pieces. There's a fabric location piece. We're using SPF to calculate where you are on the fabric. This only works on a 5-stage or larger because in a 3-stage fabric, a 3-area fabric, you cannot tell where you are because everything is symmetrical. So basically all you're doing is running SPF with a hop count of 1. You just set all your metrics to 1, run SPF, and then you just do some simple math, subtracting max from current and etc. and you figure out where you are on the fabric. And as I said, this is not something that works on a 3-stage or a 3-area fabric. We have changed the encoding. It's in bold on the slide because this is something that's changed less, and naming came out with a new draft talking about how to encode the tier level in their draft. It's an ISIS change, so we took the encoding out of our draft. We're just using theirs because it's actually simpler to merge the encoding schemes in a way that makes more sense for ISIS so that we don't have to actually manage that piece of it. Forwarding optimization or forward optimization of flooding. Essentially, we're using neighbors. If you've ever read the MANA Mobile Ad Hoc Network work, this is very similar to that in that you're using neighbors and you're deciding which neighbor of yours can reach all of your 2 hops and only flooding in a way that allows one of your neighbors that can reach all of your 2 hops to reflood to all of their peers or all of their intermediate system neighbors. This is now, this is another change in the document. We used to have a do not reflood bit and some other stuff, and we have changed this to using the local LSP in 7356. So it seems simpler to do. Go ahead, AC. Beat me up at the mic. That's AC's job. Should I back up and wait one?
I guess since he referred to me, I need no introduction. He
who needs no introduction.
This seems like this repurposing of the scoping of it's really area information, and you're repurposing scoping it at the link level to limit flooding. It seems like kind of a strange mechanism.
Yeah, but it's the simplest way to go about it, it seems like to me. The main problem you run into with ISIS is there's no header bits remaining to do anything with. So you can do different MAC addresses, which Lou Berger actually suggested on list, or you could do a new LSP type, which is what link local flooding basically does. Or there's other games you can play, but essentially, since there's no header bits to play with, you know, it's like, there are very limited options here.
But you still have to use it. You use the information at an area scope, even though
It's actually link local only, yes, but correct, yes. But you have to treat the received LSP as if it's a normal LSP, but you simply don't set this SRM bits, right? So you don't reflood it. That's actually not the way.
I think in the long term, maybe there could be a better. I don't have.
Yes. So, and if anybody has any suggestions, please send them to me, because this is very, very in the ISIS protocol, because of the way the header bits work and the fact that we're out of header bits. This is actually a pretty difficult area. So this is the forwarding up. This is the forward flooding. There's also reverse flooding, which is basically just don't flood back to anybody who is on your SPF tree towards the originator. Yes.
Xiaohu from Huawei. I have one question. On each level of the topology, beside the floodder, have you considered to choose one as a backup?
Yes, that's actually in the draft. You can do that. The goal here is to get to when you have a change, every intermediate system only receives one copy of the LSP. However, if you are concerned with weird timing problems where you don't, then you can always choose a backup and make it where everybody gets two copies. That's okay, that's in the draft. The other thing is that in the draft it talks about, this is something else Les did, or Les convinced me to do, is that there's actually a follow-up CSPF so that you know that everybody's still synchronized. Okay, because that's actually simpler than, that's like the simplest thing in ISIS to do, is that you just send a CSPF afterwards, and then if somebody has a problem, they can send a partial, and they can actually, you can actually see the failure to flood. It's actually a pretty simple mechanism. So there are two ways of handling that in the draft right now. Yeah.
Okay.
Oh, and Les is coming to the
Just
mic.
Les Ginsburg, you're talking about CSNPs, not
sorry.
SPS.
Right, CSNPs, correct, sorry, not constrained. All right. So other optimizations, there's a whole section in the draft about stuff we just don't need. There's some optimized neighbor formation stuff in there that Alvarez talked to me about. Next steps, question marks. We're just presenting it for the second time. We may or may not present it in ISIS this afternoon, depending on how many people raise their hands and say they want to see the presentation again. And, you know, we're slowly working on some implementations. There are some things swirling around the implementation space. There are some people who want to implement this and run it, but there are just some things going on as far as logistics go that are making it difficult for us to get there for this point. But questions, anything, feel free to send them to me, send them on the list. Perfectly fine. You know, this is all just open work trying to get something done.
Cool. Thank you. No questions? We are done for today, and we'll see you Friday. Thank you.